Hey everybody, how's it going? Here we are starting Unit 8 about radicals. So today we are just looking at simplifying radicals. So let's hop over to that page. So before we get started, some of you might not remember what a radical is. So a radical expression is any expression that uses a root. And what we mean by root are these little guys down here, like where you see the little kind of look like a check mark. Okay, so if there is like a symbol up there, like so right now we have this little n here with the root, that's the nth root of x. Okay, if there is no number in the upper left part of that radical symbol, it is going to be the square root. So we're going to put that in here. So it's automatically going to be the square root if you don't see any number, which most of you are used to by now. But there are other roots. So for example, down here we've got, with the 3 in the check mark, it's the cube root, or the third root of x. If you have a 4, it would be the fourth root of x, 5 would be fifth root, etc. You know the rest. So a radical is going to be the inverse of its corresponding exponent. So what do we mean by that? Well, what we mean is that the operations undo each other, just like addition and subtraction. Those are inverses of each other. Multiplication and division are inverses. So what we mean is 4 squared is equal to 16. Well, that means that the square root of 16 is going to be 4. Or if you look at the cube root, 5 to the third power is 125. So if we take the cube root of 125, that should be 5. And then same thing here with the square root in a square. Those undo each other. So what's left? Just the x. The square root of x squared is x. So what do we do about simplifying them? Well, inside of the radical sign, that is called the radicand. And if that's a perfect square or a perfect cube, depending on what root you're taking, well, you just find that root and get rid of the radical. So some of these are pretty easy, like the square root of 25. Well, what times what is equal to 25? 5. So it's just 5. No more radical or anything. Example 2, the cube root of 216. Well, you probably don't know that one in your head, so you might want to plug that into your calculator. If you need help figuring out how to do that, make sure you're asking your teacher for help. They will easily show you how to do it on your calculators. But yeah, if you take that, then you should get 6. And again, that means that 6 cubed, or 6 times 6 times 6, would be that 216. And then finally here we've got the fourth root of 81. Well, figure that out in your calculator again, or you might be able to figure out in your head, but that should be 3. Moving right along. So if it's not a perfect like square or cube inside of the radical, what we're going to have to do is use these two properties here. We've got the multiplication property, and that says that if there is a product underneath the radical, basically we can just split that up into the product of 2 radicals. Okay, and that works for any kind of root. We've also got the division property, which says if we've got the square root or radical of a quotient, 2 things being divided, well, we can change that and do the quotient of the 2 radicals. So you can take the square root of a and then divide that by the square root of b. But just be careful here, a and b do have to both be greater than 0, greater than or equal to 0. All right, so that's it. Let's move on to the next page. Page 2. So the goal of simplifying radicals is to break up the number into factors that are perfect squares, or perfect cubes, perfect fourths, depending on the radical you're working with. So let's take a peek here. If you're struggling with this, you have this tool called the factor tree. So basically what we're doing, you're taking 50 here, and we're thinking about, okay, what does 50 break up into? What factors does it have? Well, 2 and 25 are factors. And then you can think 25, well, 25 is 5 and 5. What you're looking for here are pairs. So like this guy here, you're looking for pairs. Well, 5 and 5 is a pair. So basically what that means is we're doing the product of 2, 5, and 5. Well, that guy there, that's 5 squared. And then if we take the square root of that, well, that should just be 5. So you can pull the 5 outside of the radical, and then the 2 is left inside because there's no other partner with 2 for it to come outside of the radical. So let's look here how to simplify these. So first thing I would do is plug them into your calculator, see what you get. But if you need to, we can break it up. So 225, some of you might know 225, if you split that guy up, you could go by 5s, but it actually is going to be 15 and 15. So that guy is just going to be 15. That's a perfect square. Well, how about the cube root of 40? Well, 40 is not a perfect cube, so your calculator might not tell you what that is. So we need to split it up. Now this time we're looking for groups of 3 since we're doing the cube root. So let's take a look. Let's see, 4 and 10 would be some factors. Let's see, what about 4? Then that would give us 2 and 2. 10, we could split 10 up into 5 and 2. And then that's as far as we can go. But look here, we have a group of 3 2s. That means that the 2 can come outside of the cube root. That's a bad cube. There we go. And then the 5 that's left over is going to stay in there, so we need to put him back underneath. So 2 cube root of 5. So that's our guy. Next one. X to the 5th. So when you have variables in here, let's think about this one for a second. X to the 5th, that means we're doing x times x times x times x times x, 5 of them. And we're kind of, again, looking for pairs that we can pull out of the square root. So here's a pair, here's a pair. So there's 2 of them. So that means outside of the radical, we're going to have 2 of the x's getting multiplied together, which is going to be x squared. And then, whoops, hang on. What's left underneath the radical is 1 more x that's left over. Now, a shortcut for this is if we're doing the square root, remember that's like a 2. You could do 5 divided by 2. Well, you know that that's 2 with a remainder of 1. So this 2 here, that's our exponent on the outside. And the remainder, let me make this a little bit bigger. There we go. That guy would be the exponent on the inside. Okay, so 2 and 1. Remember, no x there, or I'm sorry, no number there. That's x to the 1st. So that little trick will help you out. Okay, and then doing this, so 192. We need to think of some factors for that guy. So let's think of that. You can try some different things. It's even, so you could always try to divide by 2. But this also, if you try some other things, try some other perfect squares, well, 64 ends up being a result. And 64 times 3 are the 2 factors of 192. And then 64 is 8 and 8. So we know we can take an 8 out. And then what about x squared? Well, if we take the square root of x squared, that's just x. So basically what we're going to have here, we have our 8, we have the x that are both outside of the radical, and then underneath we've got that 3 that's left over from the 192. So 8x radical 3. All right, example 5. All right, so with number 5, we've got a cube root, so we have to be careful with that. So cube root of 64, y to the 4th. So let's start with the cube root of 64. Well, if you plug that into your calculator, that one's perfect. So cube root of 64 is just 4. 4 times 4 times 4 gives us 64. So then let's think about the cube root of y to the 4th. Well, again, with that trick with like dividing and finding the remainder, we're wanting basically a group of 3 factors that could pull outside of the cube root. So let's use our little shortcut. If we did 4 divided by 3, that would give us 1 with a remainder of 1 left over. So there's one group of 3 y's inside of that y to the 4th. So one of those can come out, one y, because y cubed is in a factor of y to the 4th. But then there is one y left over that needs to still be in the cube root. So then when we put that together, what we've got is 4y and then the cube root of y left over inside. All right, so now we start to use that division property. So again, remember, if you're taking the square root of a quotient, well, you can break that up and do the square root of each part, the numerator and the denominator. And then take a look at these. These are both perfect. What's the square root of 16? 4. And the square root of 25 is 5. So that guy is just 4 over 5. Not too bad. Okay, here's another one like that. So we know we can break that up into the square root of 8 over the square root of 9. Well, square root of 8 is not perfect, but the square root of 9 is. So we know we're going to have a 3 on the bottom. So let's think about 8 here for a second. Maybe we should split that up. What do we get? 4 and 2. And then 4 is a perfect square. That breaks up into 2 and 2. So we've got a pair there. So our radical 8, we got a 2 that comes outside of the radical, but then there's 1 2 left over inside of the radical. So here's our final answer. We've got 2 radical 2 over 3. One more here. Square root of all of this mess. So if you can, you might want to try to simplify some of the stuff that's inside of there. Or we could just go ahead and split it up from the beginning. Either way is fine. So I'm going to just split it up. So I'm going to take the square root of both parts. All right, so 3x to the 3rd. Well, the square root of 3 doesn't have any other factors, so that's not going to break down. But we've got x to the 3rd in there, so that means that there's an x squared inside of that, so we can take an x out. And we'll have one remainder left over inside of there. And then let's see, the square root of 64, that's 8, that's perfect. And then the square root of x squared is going to be x. So we've got this guy. Now again, if you can simplify, you want to simplify. Notice we've got an x on the top and an x on the bottom. So those guys are actually going to reduce. Wish I had a different color. Oh well, so this guy reduces with this guy. So then what we've got here, we would have the radical 3x inside on the top there and 8 on the bottom. That would be it. Nothing else we can do with that guy. All right, you've got a cute little puzzle down at the bottom if you want to give that a shot, see if you can solve it. Otherwise, you're done with the lesson for today. Work on your assignment and good luck.